students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with the next topic, resistors in series of chapter 12 electricity of class 10 CBSE NCERT. Okay, so let us start with the topic resistors in series. So resistors can be connected in two ways. Either can be connected in series and the other way is they can be connected in parallel. So how can we recognize that the resistors are connected in series or not? So for that, for a first resistor, if the finish end is connected with the first starting end of the other resistor, then the two resistances are said to be in series. They are said to be in series. Then the finish end of the second is connected with the starting end of the third, and so on. If the resistors are arranged in this such type of pattern, then they are said to be in series connection. So in series connection, what is the equivalent value? Today we will be finding out here what is the equivalent value and what happens to the current and the voltage readings in the circuit having the resistors in series connection. Okay, so here for this analysis, activity is being given in the NCERT books. Let us just recall that activity. In this activity, a circuit has been arranged over here, taking a ammeter, battery, key, and 3 resistors are taken. You can also take more than 3 resistors. The resultant will come accordingly. Okay. So in the activity, 3 resistors are taken having 3 different values. Either they can be 1 ohm, 2 ohm, 3 ohms, or they can be 10, 20, 30. They can be taken of any value. Okay. And a battery is being taken 6 volt, 12 volts, 100 volts, 10 volts. It's up to you. Okay. You can take any volts battery over here. And 3 resistances of different values have to be taken. Okay. Then the ammeter is being placed over here, and the ammeter, as soon as the key is plugged on, key is switched on, the current starts flowing in the circuit, and as soon as the current starts flowing in the circuit, then the ammeter gives us the reading. Ammeter gives us the reading over here. Then after the ammeter gives us the reading, note down that reading and let that reading be equal to I. Let that reading be equal to I. Okay. Now remove the connection of ammeter from here and place the ammeter here in between R1 and R2. Okay, place it in between R1 and R2. Okay, so current is entering from here and it is entering in the ammeter, and place the ammeter in between R1 and R2. Now again plug on the key. Previously, after taking the value I of the current in the ammeter, when it was placed over here, switch off the key. Then place the ammeter over here, again switch on the key. As soon as this key is switched on, again the current starts flowing in the circuit, and note down the reading of the ammeter. Now it will come out to be the same reading that was I. It will come out to be the same reading that was I. That was taken when the ammeter was placed over here. The same reading will come when the ammeter is placed between R1 and R2. Okay. Now again switch off the key and remove the ammeter from here also. Remove the ammeter from here also. Okay. And place it between R2 and R3. And place it between R2 and R3. So let us place it between R2 and R3. Okay, so place it between R2 and R3. Now again switch on the key. The connection is complete. The current starts flowing in the circuit, and note down the reading of the ammeter. As you note down the reading of the ammeter, you find that the current value is same, I. The current value is same as I. That means when the resistors are connected in series, the current is same in all the three resistors. The current flows is same in all the resistors which are in series. So the ammeter reading is same in all the cases. In all the cases, the ammeter reading is same, which comes out to be equal to I. So the current reading is same. You can now write down over here. Current reading of ammeter is same for all cases. Okay, it is same for all cases. Whether you put your ammeter here, or you put your ammeter between R1 and R2, or you put your ammeter between R2 and R3. You can also put the ammeter if there are n number of resistors over here, R4, R5, R6, R7, then you can put the ammeter between R3 and R4 and then check again between R4 and R5 and then check. You will get all the readings same over here. The readings are same in all the cases. Okay, so the current reading of ammeter is same for all the cases. So this is one conclusion which we are getting over here. Now let us check for the voltage. So for the voltage also the activity is being given in the NCERT book. So let us just recall that activity. In that activity, a connection is being made similar as it was made earlier. Ammeter is there, battery is there, key is there, and three resistors are there, R1, R2, R3, and 2 points are taken, X and Y, and a voltmeter is being attached over here. Okay, voltmeter is attached between the point X and Y, and the voltmeter reading is taken. That means we are getting the reading of the potential difference across the ends of the resistors. Now what you do, the resistances value are also different. All the three resistances are different over here, R1, R2 and R3. Again you can take 1, 2, 3, 10, 20, 30 ohms. It's up to you. You can take any of the values, but three resistance should be of different values over here. Okay, so a voltmeter is being reading is taken, and let the voltmeter reading be equal to V. Okay, let the reading be V. Let the reading of voltmeter be V volts. Okay, V volts. Let the voltmeter reading be V volts. Now, as we have done with the current, now remove this voltmeter and individually check it across the resistances. So place a voltmeter, don't see right now V2, V3, just concentrate on V1. So just place the voltmeter across R1 between X and P. So between the endpoints X and P, the voltmeter reading is being taken. Voltmeter is connected across the ends X and P for the resistance R1, and the reading is being taken, and that reading is said to be V1. Some different value we get. Suppose here the value we are getting somewhat 12 over here or 20 over here. So here the value will be different from 12 and 20. Okay, so let that reading be equal to V1. Okay, so just we are marked over here V1. So let the reading which we are getting over here is V1. Okay, now place the voltmeter across Q and S, across the resistance R2. Now place it across Q and S, across the resistance R2. So that voltmeter will also give us some other reading, and that reading, let the reading be V2. Okay. Now place it across the points T and U across the resistance R3, across the resistor R3. So we are getting the voltmeter reading as V3. And one thing we will be noticing that V1, V2, V3 are all the sum of V1, V2, V3 is equal to the voltmeter reading V, which we have taken earlier. Okay, which we have taken earlier. Suppose, let us say the voltmeter here gave us the reading equal to, suppose we are getting here equal to 20 volts, then the V1 will be, we will be getting is suppose 5 volts, then V2 we will be getting equal to, we can say suppose 17 volts, then the V3 we will be getting over here 17 plus 5 or 22, 8 volts. Okay, so 8 volts. So the sum of, okay, it would be 3. Five, 7 will give us 12 and 8. Okay. So 5 plus 7 will give us 12, 12 plus 8 will give us 20. So the readings which we will be getting somewhat like this means the conclusion which we are taking over here is that the all the sum V1 plus V2, V3, the sum of all the voltages taken across individual resistances, individual resistors is equal to the all the reading taken across the points X and Y. That means V is equal to V1 plus V2 plus V3. That means, so for the voltmeter, so for the potential difference across the ends of the resistors, we can easily say that all the summation of if we are taking the potential difference across all the resistors, that is equal to the potential difference voltmeter reading across the individual resistors. Okay, so we are getting here this conclusion over here. Now, according to the Ohm's law, we can easily say V is equals to IR, because V is directly proportional to I, and so V is equal to IR. We can easily say. Okay, so for the whole circuit, when we are taking combinedly all the resistors, we are having the voltage reading as V. We are having the voltage reading as V over here. So V, in the place of V, we can just put down IR. In the place of V, we can just put down IR. Individually also, V1 will be equal to I1 R1. Okay, it will be equal to I1 R1. V1 will be equal to I1 R1. Similarly, V2 will be equal to I2 R2. Similarly, V3 will be equal to I3 R3. But we have just now seen in this activity that the current is constant, current remains the same. So I1 is equal to I2 is equal to I. All the three cases, the current reading was coming same. So we can easily say that V1 is equal to IR1. Similarly, V2 is equal to IR2. Similarly, V3 will be equal to IR3, because the current is same in the series connections. Resistors, when they are connected in series, the current is same for all of them. Whether you place your ammeter here or here or anywhere in the circuit, the current remains constant. So the value I will be also constant. So now let us put the values over here. So from here we will be getting I R1 plus I R2 plus I R3. Okay, so we have got ultimately we can take I from here as common. Okay, we can take the I common from here. So IR is equal to I, we are taking as common. So it will be equal to R1 plus R2 plus R3. Okay, then I and I gets cancelled over here. Okay, so we are left here with R is equal to R1 plus R2 plus R3. Okay, so this is the equivalent resistance. This is the equivalent resistance when the resistors are connected in series. When the resistance are connected in series, we also denote it by RS. In some books, it is denoted by RS, depicting that the equivalent resistance when the resistance are connected in series. So the equivalent resistance is always greater than the individual resistances because it is the sum of all the individual resistances. So this thing we need to keep in mind for the numericals point of view. Also, it is very much important because the numericals come when the resistance are connected in series, and then we need to find out the current, or we also need to find out the equivalent resistance. Sometimes we are also asked to find out the potential difference across the resistances which are connected in series. So that can be also calculated by first calculating the total resistance, total equivalent resistance in series to be calculated. Okay, so in this manner we need to calculate the resistances in series, equivalent resistance in series. So two things we have to keep in mind. When the resistances are connected in series, the current is constant everywhere in the circuit. All over the circuit the current is constant, but the voltage changes. Potential difference across each resistor is different. Voltage reading, voltmeter gave different readings across each of the resistors, so the potential difference across each resistor is different, and so we were getting the values V1, V2 and V3. We were getting the values V1, V2 and V3. So thank you. So please share my videos, please subscribe to my channel, and if you have any doubt you can ask me in the comment section. Thank you.